यहाँ पर आपको एजुकेशन, एक्सप्लेनेशन, टॉप 10 क्वेश्चंस, इंपॉर्टेंट क्वेश्चंस और एग्जाम्स के मुताबिक न्यू अपडेट्स मिलती रहेंगी।
My dear students, welcome back to our channel. In this video, I will be explaining the MBA third semester subject DBMS Database Management System as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: what is data abstraction? Data abstraction in database management systems, DBMS, means hiding the complex details of the database from users and showing only the essential parts needed for their work. It helps users focus on what they need to do without worrying about how the data is stored or managed internally. There are 3 levels of data abstraction. 1. Physical level, how data is actually stored in storage, hard disk, memory. 2. Logical level, how data is organized logically, like tables, relationships, and constraints. 3. View level, what the user sees. A simplified version of data. Example: imagine a bank database. A customer using online banking only sees their account balance and transactions, view level. The database stores the data across many tables and files, logical and physical levels, but the customer does not see these complexities. Easy to remember. Data abstraction is equal to hiding complexity plus showing what matters. Why it's important? Simplifies database use for end users. Ensures security by hiding sensitive details. Makes database management easier for administrators. This concept is fundamental in DBMS because it allows multiple users to interact with the database safely and efficiently without knowing the technical details. Next important short question is: to explain data independence. Data independence in database management systems, DBMS, means that changes in the database structure do not affect the application programs or users. In simple words, you can change how data is stored or organized without changing how users access it. This is very important to reduce maintenance problems and make databases flexible. There are 2 types of data independence. 1. Logical data independence. Changes in the logical structure of the database, like adding a new field or table, do not affect applications. 2. Physical data independence. Changes in how data is stored physically, like changing file format or storage device, do not affect applications. Example: in a student database, if the school adds a new column blood group in the student table, the existing application for generating student mark sheets will still work without any change. Easy to remember. Data independence is equal to change the database, not the program. Importance: makes database systems flexible and easy to maintain. Protects applications from internal changes. Reduces cost and effort in system updates. This is a key feature of DBMS that distinguishes it from traditional file systems. Next important short question is: 3. Network model. The network model in database management systems, DBMS, is a way of organizing data where records are connected using relationships called sets, forming a graph-like structure. Unlike the simple hierarchical model, a record can have multiple parent and child records, allowing more flexible relationships. In this model, data is represented as nodes, records, and edges, relationships. It is efficient for handling many-to-many relationships and complex queries. Example: consider a university database. A student can enroll in many courses, and each course can have many students. Here, the student and course records are connected through a set called enrollment. This allows easy access to all courses a student has taken or all students in a course. Easy to remember. Network model is equal to graph of records plus relationships. Importance. Handles complex relationships efficiently. Supports flexible querying. Faster data access compared to hierarchical models for many-to-many relationships. This model was widely used in early DBMSs like IDMS and IMS. Next important short question is 4 object-oriented data models. Object-oriented data models. The object-oriented data model in DBMS combines database concepts with object-oriented programming. In this model, data is stored as objects, which contain both data, attributes, and behavior, methods, functions. This helps in managing complex data like images, videos, or engineering designs, which cannot be handled easily by traditional models. Example. Consider a multimedia library database. A movie object contains attributes like title, director, duration, and methods like play or get rating. A user object has attributes name, membership ID, and a method borrow movie. These objects interact with each other, just like in programming, and all information is stored efficiently in the database. Easy to remember. Object-oriented model is equal to data plus methods together as objects. Importance. Handles complex and multimedia data. Supports inheritance, encapsulation, and polymorphism. Makes the database closely aligned with applications. This model is widely used in applications like CAD systems, multimedia databases, and scientific databases. 5. Data manipulation operations. Data manipulation operations. Data manipulation operations in DBMS are the basic actions used to retrieve, add, update, or delete data in a database. These operations are performed using data manipulation language, DML, and help users manage the database efficiently. The main data manipulation operations are 1. Insert, add new data into a table. 2. Update, modify existing data. 3. Delete, remove unwanted data. 4. Select, retrieve specific data from the database. Example. In a student database. To add a new student, we use insert. If a student's address changes, we use update. If a student leaves the college, we use delete. To see the marks of all students, we use select. Easy to remember. Data manipulation is equal to add plus change plus remove plus view. Importance. Allows users to manage and query data easily. Helps in maintaining accuracy of the database. Supports day-to-day database operations in organizations. These operations form the heart of interacting with any database efficiently. Next Unit 1. Long questions. First important long question is: explain the characteristics of database system architecture. Database system architecture explains how a database is designed and organized so that data can be stored, accessed, and managed efficiently. The most commonly used architecture in DBMS is the 3-level, 3-schema architecture, which has special characteristics that make database systems powerful and user-friendly. 1. Data abstraction. One important characteristic is data abstraction, which hides complex details from users. Users see only the data they need, not how it is stored internally. Example, a bank customer sees only account balance and transactions, not the internal database tables. 2. Three-level architecture. DBMS architecture is divided into 3 levels. A. Physical level. Describes how data is stored on storage devices. Includes files, indexes, and memory structure. B. Logical level. Describes what data is stored and relationships between data. Defines tables, attributes, and constraints. C. View level. Shows only a part of the database to users. Different users can have different views. Example. In a college database, students see marks, teachers see attendance, and administrators see full records. 3. Data independence. Another key characteristic is data independence, meaning changes at one level do not affect other levels. Physical data independence, changes in storage do not affect logical structure. Logical data independence, changes in tables do not affect user views. 4. Security and authorization. Database architecture ensures data security by giving access only to authorized users. Example, only the admin can update fee details, while students can only view them. 5. Data integrity and consistency. Rules called integrity constraints ensure data accuracy and reliability. Example, student ID cannot be left empty or duplicated. Easy to remember. Architecture is equal to levels plus abstraction plus independence plus security plus integrity. In conclusion, database system architecture helps in efficient data management, easy access, high security, and flexibility, making DBMS reliable for real-world applications like banks, colleges, and hospitals. Next important long question is 2. Data models in DBMS. A data model in database management systems, DBMS, is a way of organizing and describing data in a database. It explains how data is stored, how it is connected, and how users can access it. Data models act as a bridge between real-world data and the database system, making database design simple and systematic. Types of data models. 1. Hierarchical data model. In this model, data is organized in a tree-like structure, where each record has one parent and many children. Example. In a company database, one manager has many employees, but each employee has only one manager. 2. Network data model. The network model allows many-to-many relationships. A record can have multiple parents and children. Example. A student can enroll in many courses, and a course can have many students. 3. Relational data model. This is the most popular data model. Data is stored in the form of tables, relations, with rows and columns. Example. A student table stores roll name, and class. Tables are connected using primary and foreign keys. 4. Entity relationship ER model. The ER model is used for database design. It represents data using entities, attributes, and relationships. Example. Entities like student and course are connected through a relationship enrolls. 5. Object-oriented data model. This model stores data as objects, combining data and methods. Example. A bank account object has balance and methods like deposit and withdraw. Easy to remember. Data models is equal to hierarchical plus network plus relational plus ER plus object-oriented. In conclusion, data models help in efficient database design, better data understanding, and easy maintenance, making DBMS suitable for real-life applications like banks, colleges, and online systems. Next important long question is 3. Differentiate between DDL and DML. In Database Management System, DBMS, databases are managed using special commands. These commands are mainly divided into DDL, Data Definition Language, and DML, Data Manipulation Language. Both are important, but they serve different purposes. 1. Data Definition Language, DDL. DDL is used to define, create, modify, and delete the structure of the database. It deals with the schema of the database, not with the actual data stored inside the tables. Main DDL commands: create creates tables or databases. Alter modifies table structure. Drop deletes tables or databases. Truncate removes all records from a table, structure remains. Example: when a college creates a student table with columns like roll no, name, and marks, DDL commands are used. Create table student, roll no int, name varchar, 20, marks int. DDL commands are usually executed by database administrators and are auto-committed, meaning changes are saved permanently. 2. Data Manipulation Language, DML. DML is used to insert, update, delete, and retrieve data from database tables. It works on the data inside the table, not on the structure. Main DML commands: insert adds new data. Update changes existing data. Delete removes data. Select retrieves data. Example: when a student's marks are entered or updated in the student table, DML commands are used. Insert into student values, 101, Ravi, 85. DML commands are used by end users and changes can be rolled back if needed. Key differences between DDL and DML. Basis DDL DML. Full form Data Definition Language, Data Manipulation Language. Purpose defines database structure, manages data in tables. Works on schema data. Commands create, alter, drop, insert, update, delete, select. Rollback not possible. Users DBA designers, users programmers. Easy to remember. DDL is equal to design the database. DML is equal to deal with the data. In short, DDL builds the database and DML operates on the data, both working together to make DBMS effective and useful. Next important long question is 4. Entity Relationship Error Model. The Entity Relationship Error Model is a conceptual data model used in database management systems, DBMS, to design databases in a simple and visual way. It shows what data is stored and how different data items are related before the database is actually created. Because of its clarity, the error model is widely used during the planning stage of database design. Main components of error model. 1. Entity. An entity is a real-world object that can be uniquely identified. Example: student, teacher, course, book. Represented by a rectangle. Each entity has attributes. 2. Attributes. Attributes are the properties or characteristics of an entity. Example: for a student entity, roll no, name, age, class. Key attribute uniquely identifies an entity. Example: roll no. Represented by oval shapes. 3. Relationship. A relationship shows how two or more entities are connected. Example: a student enrolls in a course. Represented by a diamond. Types: one-to-one, one-to-many, many-to-many. 4. Cardinality. Cardinality defines how many entities can be related. Example: one teacher teaches many students, 1 M. Example of error model. In a college database. Student, roll no, name. Course, course ID, course name. Relationship, enrolls. This model clearly shows that many students can enroll in many courses, making database design easy. Advantages of error model. Easy to understand and remember. Helps in error-free database design. Acts as a blueprint for creating tables. Easy to remember. Error model is equal to entities plus attributes plus relationships. In conclusion, the error model helps designers convert real-world requirements into a structured database, ensuring clarity, accuracy, and efficiency in DBMS. Next important long question is 5. Relational model. The relational model is the most widely used data model in database management systems, DBMS. It organizes data in the form of tables, which are also called relations. Each table consists of rows, tuples, and columns, attributes. This model was introduced by DREF Code and is popular because it is simple, flexible, and easy to use. Basic concepts of the relational model. 1. Table, relation. A table stores data about a specific entity. Example. A student table stores student information. Roll no name class marks. 101 Ravi BCE 85. 2. Attributes, columns. Attributes describe the properties of an entity. Example, roll no, name, class, marks. 3. Tuples, rows. Each row represents one record. Example, one student's details form a tuple. 4. Keys. Keys are used to identify records and link tables. Primary key uniquely identifies each record, roll no. Foreign key connects one table with another. Example of relational model. In a college database. Student table, roll no, name. Course table, course ID, course name. The roll no in the student table and course ID in the course table help maintain relationships between data. Advantages of relational model. Easy to understand and remember. Maintains data integrity using keys and constraints. Allows easy data retrieval using SQL. Flexible to add or modify tables. Easy to remember. Relational model is equal to tables plus rows plus columns plus keys. In conclusion, the relational model is the foundation of modern databases like MySQL, Oracle, and PostgreSQL, making it essential for real-world database applications. Next important long question is 6. Integrity constraints. Integrity constraints in database management systems, DBMS, are rules that ensure the accuracy, consistency, and reliability of data stored in a database. They prevent invalid or incorrect data from entering the database and help maintain data quality at all times. Without integrity constraints, databases may store wrong or duplicate information, leading to errors in decision-making. Types of integrity constraints. 1. Domain constraint. This constraint restricts the type, range, or format of data allowed in a column. Example. Age must be a number between 1 and 100. Marks should be numeric. 2. Entity integrity constraint. This rule states that primary key values cannot be null and must be unique. Example. In a student table, roll no cannot be empty or repeated. 3. Referential integrity constraint. This ensures that a foreign key value must match a primary key value in another table. Example. If a student enrolls in a course, the course ID must exist in the course table. 4. Key constraint. This constraint ensures that each record is uniquely identified. Example: Employee ID uniquely identifies each employee. 5. Not null constraint ensures that a column cannot have empty values. Example: Student name cannot be null. Importance of integrity constraints: maintain data correctness and consistency. Prevent duplicate and invalid records. Improve database reliability and trustworthiness. Reduce errors during data insertion and updates. Easy to remember. Integrity constraints is equal to rules for correct data. In conclusion, integrity constraints act as guards of the database, ensuring that all stored data is meaningful, accurate, and useful for real-life applications like banks, colleges, and hospitals.